Welcome back, dear students. We are learning some techniques to solve some of the problems which are linked with electricity and current and electricity. So here we were now heading towards other, that is calculate the resistance of a wire 10-meter long, has a diameter of 2 millimeter and resistivity that is 2.6 into 10 raised to the power minus 2 ohm meter. So it's minus 3 ohm meter. So we are asked to calculate the resistance of the wire. So basically this resistance of the wire is resistivity, which is the resistance suffered by unit length of a conductor of area cross section A. So this is the resistance formula used. So first of all, if you look at the length of the wire is given, that is 10 meter. Diameter of the wire is given, that is 2 millimeter. It means you have to convert into meter, that is 2 multiplied 10 to the power minus 3. Then you will calculate the radius of the wire, and that is divided by 2. It becomes 10 raised to the power minus 3 meter. So resistivity of the wire, the material has its own value, that is 2.6 into 10 raised to the power minus 3 ohm meter. So this is the unit of the resistivity. So here is the resistance formula which is used to calculate. If you know the resistivity of a wire, if you know the radius of the wire, if you know the length of the wire, then here is a formula which is length divided by the area for a section multiplied by the resistivity. Then you can calculate the resistance of the wire. So here is the value of resistivity. It's the length of the wire. Here's area of the wire. So you have calculated by using it this formula, that is pi r square. This is the formula which is used to calculate area of the wire. So basically, if you put the value, that is 8.38 multiplied 10 to the power 10 minus 2 plus 6, means you have added the 2, and then you are getting value, that is 8.38 multiplied 10 to the power 4. So convert into ohm, that is 0.838 multiply, that is 10 to the power 6, and 10 to the power 6 is basically mega ohm. So you have calculated the resistance of the wire in mega ohm. It was a very easier one. So if you look at what you need to calculate the length, you have to go through the given values of the length given, the radius, diameter. By you will use the diameter to calculate the radius to put the value, and to calculate the area of a wire shape, that is cylindrical shape, pi r square, that is number 2. Number 3, resistivity of the wire, which is already given. We will use this formula to calculate the resistance, and whatsoever the value is closer to 10 power, that is 10 to the power 6. So 10 to the power 6 is basically mega. So its final unit, that is 0.0838 mega ohm. So by using this technique, you have calculated the resistance of a wire after going through the given values. So if you move ahead, it's a typical 12-volt automobile battery. Here it is. Has a resistance of 0.012 ohm. What is the terminal voltage of this battery when the starter draws a current of 100 ampere? Calculate resistance, power through the resistance, and internal resistance of the power of the battery, that is small r. If you look at, that is these values are given. EMF of the battery, that is 12 volt given. Internal resistance of the battery, that is small r, it is 0.012. The current of the battery is, that is 100 ampere. You are asked to calculate R, P, power, PR, and this is the internal resistance and power of the battery due to this internal resistance. So here is the formula used to calculate EMF, that is the battery, that is IR plus IR. So if you are calculating IR, so it is basically this formula after simplification R is equal to EMF minus IR divided by I. After putting the value, this is EMF is given, R value is given, current value is given. So after putting all values, you have calculated the resistance of the battery. That is 0.108 ohm. We know that formula to calculate power is IV, and this V is equal to this one, EMF, that is. And if you put the values with 100 ampere current and the value of EMF, that is 12 volt, this is the power of the battery. After multiplying, if anyone asks you, this is the current of the battery, and this battery is so much volt, how much power it has. So you will multiply that power, that current with the EMF of the battery, then you will be able to calculate the power of the battery. For resistance, P is equal to IV and V is IR. You multiply with these two from this formula, V that is equal to IR, and if you put the value of IR in this formula, you will be getting I square. This I will be multiplied with I square, and the R. So the power formula is this one. After putting the values of the current and the resistance which you have already calculated, this one, you are basically getting the resistance. So power decrease resistance, that is 0.108. So for small resistance, we are using PR, that is I square R. This R is the internal resistance of the battery. Its value is 0.012. And after putting the values of this and simplifying 10 power and 1000 and multiplying with the resistance, internal resistance, if you multiply, you are getting 120, and 120 is the unit of 120 watt. Watt is the unit of power. So what you have done, first of all, you have calculated the resistance after looking at the values, given values. Then you have calculated power. Power is equal to IV. Then you have calculated power due to this resistance. Power after this resistance, that is I square R. Already you have calculated capital resistance, and then for small or the internal resistance, you have used this formula, and after putting values in this formula, you came to know that our one formula which you have seen, that is P is equal to IV. It is the formula of the power. By using Ohm's law, V is equal to IR. After putting IR, we are getting this formula, and it is calculated by using the basic concept of the Ohm's law. So here it is, if your current is given or potential is given, you will multiply these two, you will be able to calculate the power at that time. But if the value of the current is given and potential is not given, resistance is given, then basically it is simplified from this formula. And after putting this formula in this, you have calculated basically power. Both have the same meanings. To calculate the power, sometimes potential, directly potential is given. Sometimes the resistance is calculated by using the value of the potential, that is V is equal to IR, and then you will be able to calculate the power. So with this, I hope you people have understood the technique to calculate the power resistance. Thank you very much.